Hello and welcome to the webinar. My name is Stephen Springhorn and I'm the Acting Deputy Director for Statewide Groundwater Management at the Department of Water Resources. And along with my colleagues, we'd like to thank you for taking the time to tune into the webinar today. Our team, who I'll introduce in a minute, is excited to be providing an overview of and answering your questions about our upcoming statewide Airborne Electromagnetic or AEM surveys. Our team has been working hard to get this effort off the ground starting this summer, and it will continue over the next several years. This statewide AEM survey effort is one part of DWR's Sustainable Groundwater Management Act, or SGMA, technical support and assistance, which is aimed at providing data, tools, and information to groundwater sustainability agencies, the broader SGMA community, and the public to support successful SGMA implementation. This effort is impressive in its scope and scale, covering California's roughly 100 high and medium priority basins where this type of data collection is feasible. And as you'll hear more today, this effort will enhance our collective knowledge and understanding of our groundwater basins, which in drought years like we're experiencing now, are the source of almost 60% of the state's entire water supply. So more specifically, this information generated and made publicly available through these surveys will support the continued development and refinement of hydrogeologic conceptual models, as well as groundwater models, to be filling those data gaps and improving the identification of groundwater recharge areas as just one example. So all of this is intended to support the development and continued implementation of groundwater sustainability plans, and also to support the state's overall goal of improved understanding and management of our important groundwater resources. So I'd like to introduce our AEM project team that's here today, starting with Catherine DeLubac from DWR's Sustainable Groundwater Management Office in Sacramento. Catherine is our AEM project manager and will be providing additional details on the AEM project scope, schedule, and next steps during her presentation. And Tim Godwin and Ben Brezing are also here today and are on our AEM project team, working out of the Sustainable Groundwater Management Office in Sacramento as well. And they'll be assisting with the question and answer session at the end of Catherine's presentation. And I also wanted to mention that we've had the opportunity to assemble a great contractor team led by Ramble to support us in this implementation of this big effort. So as we continue the webinar today, I really encourage you to ask questions using the instructions that will be provided in a second, and we'll do our best to answer them during the question and answer session at the end of the presentation. And so with that, I'll turn it over to Catherine, and we really thank you for your interest in this effort, this exciting project, and we're really excited to be kicking it off. So take it away, Catherine. Thank you.
Great. Thank you, Stephen, for that introduction and for that overview of the project. Yes, so hello all, my name is Catherine DeLubac. I am the project manager for the statewide Airborne Electromagnetic, or AEM surveys. And I'm really happy to have the opportunity to be sharing the project details of this exciting project with you all today. So welcome, and again, thank you for joining. And so just to note, this presentation is being recorded, and both the recording and the presentation slides will be available to you all on our AEM project website later this week or in the next few days. Okay. So, just a second here. Let's see. There we go. Okay, so I'll start out with an introduction to the presentation, giving you an overview of the presentation. I'll start out with an introduction to the AEM method itself and how the data can be used. I'll then provide you information about the safety of the method and where other AEM surveys have been conducted. And I'll then go into all of the details about our statewide survey implementation and our outreach plan. I'll then put out a request for relevant existing data, and I'll be alluding to this request all throughout the presentation. And then, as Stephen said, we'll have about 20 minutes saved at the end of the presentation for a public question and answer session. And again, if we don't have time to get to everyone's questions, we will do our best to get back to you in the next few days. So we have the public question and answer session at the end of the presentation today, but I encourage you to ask questions throughout the presentation. You can do that by going to, if you're on GoToWebinar, you can go to the questions tab and the GoToWebinar dashboard, and you can type in your question, sending it to the organizers and panelists. If you're calling us, then you can send any questions that you have to our project email address. That's aem@water.ca.gov. And again, we'll be compiling these questions and going through them, as many as we can, at the end of the presentation today. Additionally, if you're looking for more information, you can visit our project website. That's at water.ca.gov/programs/sigma/AEM. Alrighty, so getting into it, the introduction to the method and the data use. So AEM, the Airborne Electromagnetic Method, is a geophysical method in which the equipment are towed beneath the helicopter. And let me bring up my little spotlight here. And they're towed beneath the helicopter in this rigid loop, or the equipment is housed in this rigid loop, towed beneath the helicopter. And as we fly over the surface of the Earth, we send signals into the subsurface. Here shown as these cartoon yellow cylinders into the subsurface, and we measure the response of those subsurface materials on instruments that are also mounted on this rigid loop. Specifically, what we're measuring is the electromagnetic response of subsurface materials. And as we fly over the Earth, we can create this two-dimensional image or a cross-section showing the distribution of the electromagnetic properties of subsurface materials. Specifically, we can display them as the material's electrical resistivity, which describes a material's ability to resist an electric current, or the material's electrical conductivity, which describes the material's ability to conduct a current. And so here's an example of that two-dimensional image, and you can see that materials with a higher resistivity, are shown here in purples and reds, are located on the top of the image. And the materials with the lower resistivity or the lower conductivity the materials with the lower resistivity are shown here in the shades of blue. And in California, we can see down to a depth of about 1,000 feet using this method. The vertical resolution of the method varies with depth. In the near subsurface, the vertical resolution is on the order of 5 to 10 feet. And then at depth, the resolution increases so that at depth, we can see layers with a thickness of 100 feet or more. Okay, and as we fly over the surface of the Earth in a grid or in a pattern, we can collect data and display it as a two-dimensional, as a three-dimensional fence diagram. So here we've collected two-dimensional data along these different grids, and it can be displayed in a three-dimensional fence diagram. And this is an example from Stanford University, where they're displaying the AEM data in this three-dimensional space above the surface of the Earth. Right, but we don't actually care about the electromagnetic properties of the subsurface materials. What we actually care about are the material properties. And here are some material properties over here on the right, as I'm showing you on the schematic. Here on the top, we've got resistivity, which increases to the right. And on the bottom, we have conductivity, which is increasing to the left. And so this shows the relationship of how the electromagnetic properties are related to the material properties. In California, we're especially interested in these unconsolidated materials. And so here we have these, let me see if, I'm sure you can see this. Here we have gravels and sands, which as you can see, typically have a higher electrical resistivity. And materials like clays and silts typically have a lower electrical resistivity or a higher electrical conductivity. And so we can further define this relationship between the electromagnetic properties and lithology by creating site-specific resistivity to lithology relationships using existing data. So the types of existing data that we use to create this relationship include lithology logs, geophysical data, groundwater quality, specifically the amount of total dissolved solids in a pore space material, and groundwater levels. And so here's an example of a site-specific resistivity to lithology relationship, where you can see there's a specific range of resistivities that correspond to a granite, specific range of resistivities that correspond to a sand and gravel, and a clay saturated with fresh water. And here's an example from Ramball where they're showing in the background the AEM two-dimensional data, along with lithology logs shown here. And you can see that the AEM data now have been interpreted for lithology, where we have a top layer that's interpreted for a sand. We then have another layer here interpreted for a clay. Below that, we have a clayey sand. And then we have a sandy clay and a clay in this area. So now that we have the AEM data interpreted for lithology, how can we use it? Well, as Stephen was describing, we can use the AEM data to help to refine or to define a groundwater or hydrogeologic conceptual model. Here's an example from AquaGeo Frameworks, where they've collected the AEM data along these lines, and they've interpreted that data now for lithology. The specifics aren't important for this demonstration, but you can imagine that if you were creating your groundwater model here, let me grab my highlighter. You can see that if you're creating your groundwater model, you might be interested in determining where the separation is between these two different types of lithology. Or if you're creating your hydrogeologic conceptual model, this type of information might be useful in filling data gaps. Additionally, we can use this AEM data to help us to cite possible recharge areas or to define areas where we need to conduct additional investigations. So here is an example from Ramball, where here the AEM data have been interpreted for sand. Here's the water table. This area is showing a clay. We have here faults that have been interpreted. And you could imagine, as an example, if, let's say, you wanted to cite a recharge pond in a specific area, perhaps assuming that you would be able to extract those in a well towards the northeast, the fact that you have a hydrologic barrier in this area might be important in your determination of where to cite a recharge pond. Alternatively, you might want to better understand the extent of this newly found hydrologic barrier. And in that case, you'd want to go out and conduct additional studies. You can also use it to help determine, better define where you have clays that are susceptible to compaction and may result in subsidence. So here's an example by Knight et al., where they're showing an upper aquifer, the Corcoran clay, and a lower aquifer. And you can imagine it might be important, and here are the clays in blues, the mixed fine and coarse materials in greens, and sands and gravels in yellow. And it might be important to you to define where you have clays located in the subsurface that, again, might be susceptible to compaction. You can also use the AEM data to help define areas that have a high amount of total dissolved solids within that pore space fluid. So here's an example from Stanford, where they've interpreted this AEM data now in a 3D space for fluid that has a high concentration of total dissolved solids, or TDS. And here they're just mapping where those high concentrations are in the subsurface. So those are a few examples of how we can use this AEM data. But of course, there is data uncertainty, as there is with most things. And so one thing that we can do with the AEM data is acknowledge that data uncertainty exists and try to find the best way to communicate that data uncertainty with stakeholders and decision makers. One thing we can do is we can look at the coarse fraction probability, and this is from a report by Stanford University, where they're looking at the coarse fraction probability. So one would be that there's a 1% or a high probability of a coarse material, shown in red, and 0 would be that there's a very low or 0% chance of a coarse material, or a high percent chance of a fine grained material. So you can see that that's shown here in this 3D space. Let me turn my highlighter back on. Where in the reds, you can see that those areas, then you have high reliability of a coarse fraction of a coarse material. In blues, you have a high probability of a fine material, and in whites, you're not sure. You're a bit 50-50. So the good news is that we can reduce this uncertainty by incorporating high quality existing or new data. And again, those types of data are shown here. Okay, so that was the introduction to the method and the data use, and I'll go into a little bit about the safety now and where other surveys have been conducted. So during a survey, the helicopter itself flies at about 200 feet above the Earth's surface, and it carries the equipment about 100 feet below that. So it flies, the equipment's at 100 feet above the Earth's surface. The equipment itself doesn't generate any noise, but there is noise generated from the slow flying helicopter. The noise that's generated, though, is less than that of operating a lawnmower. So it's not expected to be a very large nuisance. And the surveys are flown by professional, experienced, and licensed pilots that follow all federal, state, local, county regulations. And then the surveys themselves will not be conducted over urban areas or buildings or structures that contain people or livestock. They also won't be conducted over military bases and other defined Federal Aviation Administration no-fly zones. So this technology is relatively new to us in California, but it has been used extensively both nationally and internationally. And so here what I have for you are a few examples from surveys conducted both within the states and outside. Here's an example of a survey that's currently being conducted by the USGS in the Mississippi Alluvial Plain. This is a survey that's being conducted across Australia. Here's an example of a survey that's being conducted in Wisconsin. This is an example of some of the data that's being collected in Nebraska. And here's an example of some of the data that's being collected in Denmark. And so each of these is a live link, which will be provided. And so the presentation will be provided to you all after. And so I encourage you to have a look at each of these agencies' websites to get more information about what these folks are doing, because there's some really interesting projects going on out there. Additionally, these surveys have been conducted in California through a set of pilot studies. These pilot studies were conducted in 2018 through 2020. And I'm showing you the locations of the pilot studies here. They were conducted in Butte and Glenn County, in San Luis Obispo, and then also in Indian Wells Valley. And so the purpose of these pilot studies was to show that AEM data could successfully be collected in California and to provide recommendations on the future data collection. And so these surveys were led by Rosemary Knight and her group out of Stanford University, with participants from other academic and private sectors, as well as other local and state water agencies. And so all of these reports and the data can be found on the California Natural Resources Open Data Portal. And many of the examples that I provided today are actually from these reports that are on the Open Data Portal. So I encourage you to go and have a look at some of these. There's really interesting results that were found. Additionally, you can visit the pilot study website. That's Stanford's website at the Stanford Groundwater Architecture Project. Again, lots of good information there as well. Okay, so moving into our specific survey implementation, what are we doing here in California? So first with the project implementation, well, this project is funded through voter approved Proposition 68 and the general fund. So there's no additional cost to GSAs for the collection of this AEM data. As Stephen mentioned, we'll be collecting the data in all of the high and medium priority groundwater basins where data collection is feasible. So as I mentioned, we cannot collect data in urban areas, and so basins that are highly urbanized, we won't be able to collect data in those basins. We'll also be collecting data in some basins that are not high or medium priority basins, but are, for example, between two high and medium priority basins for which we would need to fly through anyway. We'll also be collecting some data in other non-high and medium priority basins if there is a state or federal interest in those specific basins. So the surveys will be conducted again starting this summer, and they'll be continuing over the next several years. As Stephen said, we're contracting with a really great team. We're working with Ramball, SkyTem, Sinton, Helicopters, and Aarhus University. And these are a set of folks who are very experienced in the collection of AEM data, both nationally and internationally. And the same group of folks worked on those AEM pilot studies here in California. And we're also working with GEI, AECOM, and Stantec. And so this is a group of consultants who have extensive experience supporting both the DWR and GSAs with their with the implementation of Sigma. So a really great team we have on board. And what will we be doing? We'll be collecting data in a coarse grid of an approximately 2 by 8 mile line spacing, again, in all of the high and medium priority basins. And this is what I'm showing you here. This is an example of this 2 by 8 mile grid. And here's just a zoom in to this area near Merced, where you can get a better understanding of the density of this line spacing. So the purpose of the density of this line spacing is that what it really will do for us, it will improve our understanding of our large scale local and regional aquifer structure. And what it can do is it can also be used as a framework data set to help us identify additional areas or areas for additional investigations. Those could be additional fine grid AEM surveys. Those could be going out and collecting more borehole data, or it could include going out and collecting totem data, which is the same type of technology that's used in AEM, except this is deployed from the surface of the earth, towed on the back of an ATV. And so in defining these flight lines, we'll be orienting the grids, these 2 by 8 mile grids in each basin, to capture the major geologic features. So if there is a known fault orientation, or if there are stream channels, buried stream channels that are important to GSP development or groundwater management, we want to orient the grid so that we're really capturing those major features. The survey flight lines will then have to be further edited to avoid noise sources. And again, data won't be collected over restricted areas. So those urban areas that I was mentioning. Additionally, the survey lines will be, again, further edited, given input from GSAs and state and federal agencies to cover important areas. So important areas would be areas with known data gaps, areas that are being considered for groundwater recharge projects, or areas that are just critical to the successful implementation of SGMA. And I want to clarify that we're not changing here the grid density, but instead what we will do is we'll be shifting the lines so that we're making sure that we cover those important areas. So here's an example. Here's an example of a 2-mile spacing. Here's the 8-mile approximate spacing. And in this example, we asked the GSA for to identify their possible recharge areas, which I identified as here. We can see that with our original 2-mile spacing, we would have missed this recharge area. So what we will do here is then shift our line a 1/4 mile or so to make sure that we cover this potential recharge area. And that's what I mean by editing the flight lines for important areas. Okay, and so the surveys, we will also be surveying based on survey areas. And so all of the high and medium priority basins that we'll survey will be grouped into approximately survey areas. Each survey area will consist of between 1 and 8 groundwater basins, depending on where the basin is located, its proximity to other basins, and the size of the basin itself. And again, we'll be collecting collecting data in all of these survey areas over the next 3 years. And so here, each of these color, turn this on, each of these color codings is an example of where a given survey area would be. And here what I'm showing you is our example 3-year survey schedule. So here on the left, we have each of these survey areas. Again, each survey area corresponding to each one of these color codes. And then on the top, we have our 3-year schedule. Within each of these schedules, we have a couple of months kind of tanned out for typical fire season or typical rainy season, so that in the end, we'll be surveying these different areas within groups. And so here we have 5 groups laid out throughout the next 3 years. Then for each one of these survey areas, you can see that there are several months of pre and post survey tasks, and that's what I'm showing you here in gray. Then the surveys themselves are shown here in red, and those are quite quick compared to the time needed for the pre and post survey tasks. Additionally, what I want to note or highlight is that the data itself from an AEM survey won't be available until at least 6 months after the surveys are conducted. Okay, and so this first survey group 1 has already been defined. If you've visited our website, you've seen that this survey group has been posted. And this survey group includes the Salinas Valley, from the town of Salinas down through Paso Robles, and then also Cuyama. And these surveys, again, will be starting this summer, so they'll be starting in July and going through August. And we've already reached out to these GSAs and state and federal agencies, and the survey lines are already being developed. So for the rest of the basins out there, I think there's probably a question about when will my basin be surveyed? So I wanted to give you some information about how we're developing this schedule. So within each survey group, we'll be surveying basins that are both located within the Central Valley and the surrounding northern, southern, or coastal basins. So that means that within the Central Valley, so that means within a single group, again, we'll be surveying basins within the Central Valley and a surrounding basin. Within the Central Valley, we'll be starting the surveys in the south and moving north. In the surrounding basins, we'll be prioritizing those basins by the amount of digitized existing data that's available, or the percentage of that basin with disadvantaged communities. Our schedule also has to consider several other things, including weather, the time needed, and restrictions of local permits and regulations, and also tribal concerns, or if there are any sensitive times to tribes. So several things to consider. We will keep the survey schedule updated on our AEM website. So here is a link to our story map, which has both a live map that shows the locations where the AEM survey is being scheduled, not yet scheduled, and of course later this will include information like data available, or data available or data being processed, things like that. We'll also have the table on this website showing you which basins are being covered and their approximate survey dates. And again, these will all be tentative because we really need to be flexible for weather and fire conditions. And after the surveys are conducted, of course, all of the data sets and reports will be made available on our California Natural Resources Agency Open Data Portal. This will include all of the unprocessed, processed, and interpreted AEM data, as well as all of the supporting data that's needed to process and interpret the data. And that's because here at DWR, we realize that what we're doing is providing you all with an interpretation of the AEM data. Now, as more data becomes available, more existing data becomes available, and as processing techniques are improved over time, it's possible that these interpretations could be changed. And so we want to make the AEM data available to you all, to be reprocessed and interpreted as more data become available. And we also have a goal to provide tools and guidance on how the AEM data can be used and integrated into groundwater and hydrogeologic conceptual models after the data are collected. And this is really in alignment with the Sustainable Groundwater Management Office's Technical Assistance Section's goal of providing data and tools to groundwater sustainability agencies in support of the development of GSPs. And so this is obviously going to be a very, we can't hide behind this survey. This is going to be very visual. Folks will see the helicopter out there as well as this equipment. And so we need to be conducting extensive outreach to support these surveys. That starts out with this public AEM webinar right now. So thank you all for joining us for it. And then the public outreach will continue across each survey area prior to conducting a survey. It will be held a few months before the surveys are conducted. So we'll be reaching out to GSAs, we'll be having outreach to the public, and then also to tribes. For GSAs, this pre-survey outreach will include pre-survey meetings with GSA representatives, and the purpose of this will be to notify GSAs of the upcoming surveys, and then also to get information about those important areas, so that it's those important area maps, so that we can incorporate that into our flight line planning. We'll also request GSA support, and more details about that will be provided during those pre-survey meetings. We'll be conducting outreach to the public also prior to the surveys, and this may include mailers to residents beneath the flight paths, and newspaper articles or radio ads in local media outlets, really announcing that these surveys will be conducted in the coming weeks. We'll also be coordinating with the GSAs on sharing outreach materials that we've already developed with GSA stakeholders. So fully appreciating that GSAs have already developed that relationship with the stakeholders and providing them with materials that they can share with the stakeholders. and then tribes as well. So conducting outreach to tribes specifically to share with them how AEM data can support their groundwater management, and then also to get input from them on the schedule development. Again, wanting to make sure that we are incorporating any sensitive times in our schedule development. And so here's just here are some of the outreach materials that we've developed that I alluded to in that previous slide. So we've got our AEM website that I'm showing you here that you can access, and then we've got a lot of materials already developed, already available on our website, and we have newly added to our website our short 2-minute AEM video, which provides a brief introduction to the method, which is a great way to just get an introduction to what these surveys are about. And then we've also added an FAQ to the website as well. And these other materials will be made available through the website or directly through directly to GSAs. We're also coordinating on this project with other folks. So we're coordinating with other state and federal agencies through working groups. And that's for them to provide us with information that we can incorporate into ensuring that these AEM surveys are multi-benefit. We also want to get information from these other state and federal agencies about important areas to fill in their data gaps or where they might be considering projects so that we can incorporate that into the flight line planning. And then also to share existing data. Again, those lithology logs, those geophysical data that I've been mentioning throughout this presentation. We'll also be creating a technical advisory committee, or a TAC, and the purpose of the TAC will be to provide recommendations on defined issue areas for the program's continued development. This will include about 10 or so invited members that are international, federal, state, and local and academic practitioners and experts. And so we're hoping to have this TAC developed and up and running in the coming months. Okay, so that is what I have for you for the introduction to the project and the method and what we are specifically doing with our statewide survey implementation. And now my request for existing data. So existing data, why we need it and what we need. And as I already mentioned in the presentation, why we need existing data is because it supports the reliable interpretation of the AEM data. It helps us to define that relationship between the geophysical properties that we're measuring and the aquifer properties that we're actually interested in. So what specifically we're after, again, we're looking for lithology logs and geophysical logs. We need to use data that's not just digitized, or that's not just scanned PDFs, but rather has been digitized data. And we're looking for high quality data. So data that have good lithologic descriptions, or where the wells have been accurately located. And so our typical compilation process for gathering this relevant existing data would be to go to one of the databases that we operate, Oscar, CalGEM, for example, and gather those lithology and geophysical logs. We would then sort them to determine which logs are high quality. And then we need to go through and ensure that we have the accurate locations of those wells. And then to do the last step of actually digitizing the logs. And so what we realize is that GSAs may have already completed much of this work while developing groundwater sustainability plans. And so it's our goal not to be repeating work that's already been conducted, but really just to build off the work that GSAs have done. And so we're requesting relevant existing data. And the type of data that we're requesting are lithology logs that have been digitized. If you haven't digitized your logs, but instead you've gone through and determined the accurate locations of wells, we'd love to have that the information about the accurate well location. Or if you've just even sorted through logs to determine a list of your high quality wells, or the wells that you typically use when you think about your hydrogeologic conceptual model, that would be great as well. in terms of geophysical data, we're looking for really any and all geophysical logging and surface data that are available. It doesn't need to be digitized, and we will do the digitization ourselves. And the amount and location of the data, we're looking really for any and all data that's located across the basin. As I said, that we'll be conducting these surveys across the entire basin. And one of the things that we'll consider when developing these survey lines is where we have existing data. So really, I wouldn't limit the data that you provide on extent. Really across the entire basin is great. And then I also want to highlight that there's no additional work that we're requesting from GSAs here. We're really asking that if you have already done any of this work of digitizing or determining accurate locations of the wells or just determining the high quality wells, we're just looking to use that as a starting point to move forward in this. So again, no additional work requested from GSAs. And so I just wanted to go briefly through the process of how to submit the data. And the information about data submittal and the types of data that we're after are all provided in an existing data fact sheet, which is available from the AEM website under a GSAs tab. This is just a little snippet of that existing data fact sheet. So everything I'm going to go over here now is available in this PDF. So the first thing you're going to do when submitting data is to fill out a point of contact form. This is a link here to that. And this point of contact form is really for our team at AECOM and GEI and Ramble to have someone to contact at the GSA in case we have questions about the data. So this is really, again, the point of contact for this existing data. You can then submit the data via the send file system, and we have AECOM. This is AECOM's send file system, and they are compiling the data for us. Again, there's instructions in the fact sheet on how to do this, but you need to put someone specific in the recipient email address. And then we have also a few questions about the data itself that we'd like you to put here in this subject. But again, information about that in the existing data fact sheet. Okay, so let's see. I think that is all I have for the relevant existing data that we're after. And I think we have some time for question and answer.
All right, well, thank you, Catherine, and thank you, everyone. That was a lot of great information, and we have a lot of questions coming in, so we can start the Q&A portion of the discussion now. And Catherine, if you could go to the slides and just do a quick reminder of how to submit your questions.
Great, yes. So again, if you have questions that you want to submit, please go to the questions tab in the GoToWebinar dashboard, and you can type your question in to the organizers and the panelists. Or if you're calling in, you can send us an email at aem@water.ca.gov. And again, for more information, you can visit our project website, which is right down here.
All right, great. So we can start with the questions. And again, if we can't get to every question today, we'll do our best to follow up in the subsequent days after this presentation. And again, the presentation is being recorded and will be posted along with the slides on our webpage, as Catherine mentioned. Okay, so introducing Tim Godwin, again, a key member of the AEM project team. And Tim, if you could start reading off the questions and identify who the question is for on the panel.
Yeah, absolutely. So why don't we dive right in? Question for Catherine, a little bit of technical here. How does the vertical data resolution change with depth?
Yes, thanks. So the vertical resolution will increase with depth. So in the shallow subsurface, the vertical resolution, or the thickness of the layer that we can see, is on the order of 5 to 10 feet. Now at depth, the thickness of that layer that we can see will increase to the order of 100 feet or more. So it has a greater thickness at depth.
Excellent. And again, Catherine, since you're up, can you talk a little bit about how uncertainties in the inversion results and interpretations will be handled?
Yes, so I didn't mention the uncertainty in the interpretation and the inversion. So yes, so there is uncertainty in a few different aspects of the AEM data collection process, interpretation, and inversion. Right. So the uncertainty in the inversion and the interpretation, we're going to be working with our technical advisory committee and also with our consultant to figure out the best way to communicate that with the public. And one way to do that could be to show the data in terms of the percentage or the certainty of a certain type of material. So a certainty of a coarse material, a certainty of a fine grained material. And so one way to do that again is through that coarse fraction probability.
Great. Stephen, why don't we go to you? Why are AEM data not being collected over the Owens Valley nor in the Mojave Desert region of Southern California? Maybe you can talk about a little bit about the scope and region of our project.
Yeah, thank you, Tim. This is a great question. And, we know that we have 515 groundwater basins in the state, and about 94 of those are high or medium. And, with the funding we have and how that funding was allocated to us with what instructions on how to spend the money, it really was focused on high and medium priority basins in California that are required to do SGMA. And so that's where we have to spend the money that we have as it was directed to us. So that's why we are focusing on the high and medium priority basins at this point in time. I think with this information and this whole effort, as Catherine mentioned, it's going to allow us to have a lot more information within these basins, but also develop processes and guidance on how to do AEM in the state. As more data, or I should say more funding, if it were to come available, we could start to think about how to expand these surveys into other basins that are low or very low priority at the moment.
Great, thanks, Stephen. You answered a couple of questions there all at once. Good job. Just as an additional follow-on though, so within our existing scope of work and the areas we're flying, could a GSA provide additional funding if they desire to have a finer grid flown for their area? Stephen?
Yeah, Catherine, do you want to touch on that one?
Sure, yes. So within the coarse grid that we're collecting, we are not working with GSAs to also collect fine grid data at the same time. So we'll be collecting the coarse grid initially, but GSAs can then contract with the contractor themselves and go back and collect fine grid data. So we're not collecting fine and coarse grid data at the same time.
Great, thank you. Catherine, since you're talking, we'll keep going down this road. Well, one, it's a compliment. Cool work, This is really relevant data for GSAs, and the question is really, are we going to leverage the conceptual models, the hydrogeologic conceptual models that GSAs have prepared as input for our surveys, and is that valuable information?
Yes, that is a good point. So that's something I didn't actually mention explicitly here when I talked about existing data. I didn't say specifically the hydrogeologic conceptual model that GSAs have already developed in terms of providing them to DWR, but yes, those are absolutely a great starting point for us in better understanding if you have a hydrogeologic conceptual model that exists that can help us to, again, support the interpretation or the inversion of the AEM data. It can also help us to better define where we need to conduct the surveys or how we want to orient those grid lines. Again, if the hydrogeologic conceptual model tells us that there is a preferred orientation for a buried channel, for example, then we can make sure that our grid is oriented to capture all of the heterogeneity associated with that survey channel. So yes, I would say that it's definitely information that's helpful for us, and we would encourage you to provide, if you have a digital hydrogeologic conceptual model, to us using that same send file system. I think that would be really helpful. Yeah, so thank you for that question.
Yeah, and maybe a little bit about the output. So what will the format be of the AEM data? What's our final product? Questions: is electronic? Is it a conceptual model? Is it going to be shared publicly? Maybe you can talk a little bit about that.
Yes, okay, great, thank you. So all of the data, as we mentioned, will be shared on the California Natural Resources Open Data Portal. What we also hope to do, and didn't specify here in this presentation yet, is the fact that we also would like to create an advanced data management system that is more specific to geophysical data and the types of supporting data that we're collecting in this specific project, that will help us to better share that with the public. So that's still to be developed, but on our to-do list. So in terms of how the data will be formatted, we'll have data that's available to the public and to folks at various different stages of the AEM processing and interpretation and reports process. So the data will be available in the same type of format that it's collected from the AEM instrumentation directly, for those folks who want to work with that data as it is and reprocess it and reinvert it. So it'll be available in that format. It'll also be available in a report with a write-up, and also with PDF, of course, showing those images of those cross sections. And then as we start going through and working through this first survey area, what we'll be doing is starting to think about, what additional formats are most appropriate, or that the GSAs are finding are the easiest for them to use. So we'll, of course, be welcoming your feedback on this first survey area. If there is a specific format that you find better to use, if you're using a specific type of data viewer, then please let us know, and we can try to make sure that we have the data available to you all in whichever is the most appropriate format for you.
Great. So let's see, a couple of questions I'm gonna mash together here. Can you tell us a little bit about our plans for flying over oceanfront basins, and how we're going to map in offshore aquifers, or what our plans are for that seawater intrusion interface?
Okay, thank you for that question. So this is a little bit tricky, because obviously seawater intrusion is a problem along several areas, several basins along the coast. Unfortunately, several of these basins also have a very high urban population, which makes it very difficult for us to collect AEM data in these areas. And so where we can collect data along the ocean front, we will. And again, in those dense urban areas where we can't, the Los Angeles area, for example, comes to mind, then we won't be collecting data in those basins. So I guess in short, we'll try our best along the coast, but there are difficulties.
That's great. A question regarding federally recognized Indian tribes. Can you talk a little bit about our plans for outreach and communications prior to our flights?
Yes, okay, thank you. Yes, so we will be working with our own DWR's tribal policy advisor to reach out to different tribes and to share with them a little bit about what we're doing with the surveys themselves. So a similar presentation to what we gave today, and sharing with them information about the method and how the AEM data can be used. And then also getting from them information about whether there are sensitive times during the year where they would prefer the surveys not to be conducted. Of course, we want to incorporate that into our flight line planning process. So, so tribal outreach is something that we will be doing here in the next coming months. And yes, and so it's something that yeah, we'll definitely be working with our different tribal policy advisors and different folks within our different region offices who also work with the tribes to be making sure that we have adequate communication and with tribes.
Great, thank you. I'm going to combine another couple of questions here, and it's really about why is it that AEM data can't be collected over urban areas?
Great, so that is a good question. Well, there are a few different reasons. So one is that there are a lot of noise sources in urban areas. Noise sources in terms of the sources of noise to the AEM data itself. So roads or different areas where we have pipelines or power lines all create electromagnetic noise in the AEM data. Additionally, there are Federal Aviation Administration restrictions to flying over structures that contain people or confined livestock. So that's really the reason that we're not flying over urban areas.
That's excellent, thank you. I guess some questions about our schedule are coming up in terms of when do we anticipate being able to publish our anticipated schedule for the remainder of the flights? We have some on our web map currently. They're just looking for some planning.
Yes, okay, well, thank you. So we do hope to keep that schedule as updated as we can. So we will be posting this next survey group 2. The schedule for that group probably within the next month. And then we will be posting the schedule after that as soon as we can. But of course, as I mentioned earlier, we'll be developing that schedule for those for the surrounding basins, the basins surrounding the Central Valley, giving priority to basins that have a significant amount of digitized data available. So it's going to take us some time to collecting that digitized data in order to prioritize those surrounding basins. But again, we will post this survey group 2 within the next month, and then we'll be posting the rest of the survey areas as soon as possible.
There's a couple more questions. I just like to say, we'll follow up with you on some of these remaining items. We're running out of time, and I want to provide some time to close here. But one last question: Can you talk about whether the flights will be conducted solely within the basins, or will they extend to the margins of the basins where they're contacting hard rock? What's the plan there?
Yes, so the majority of the surveys themselves will be conducted within the basin. There will be some lines that go external that are outside of the basin. And really we'll be communicating with other state and federal agencies about their interest in the areas surrounding. So as an example, in the Salinas Valley, in the Cuyama area, we also had coordination with the USGS and with the California Geological Survey about their interest within the basin in the areas surrounding the basin. And so in the Salinas Valley, for example, we do have survey lines that go outside of the basin to map various faults of interest to the California Geological Survey or other areas of interest to the USGS. So it will be basin dependent whether we fly outside of the basin at all, but it is possible in some specific.
Great. So we're right at 12:59 now. I'd like to be respectful of everybody's time. Allow Catherine and Stephen some closing comments.
Okay.
All right, well, thank you, Tim, for asking those questions and answering those questions, Catherine. And for everyone on the line, really appreciate your interest in this exciting project. Thank you for all the questions today. Again, we will do our best to answer the ones we didn't get to today, but this is really the first step It's a very big step, as Catherine mentioned, with all these basins that we'll be covering over the coming years. But it really shows that our collective work to better understand California's groundwater, which we know is so important to our state, and there's just so much work going on. And this is just another example of how we in the state are collaborating, working together, and investing in getting a better understanding so we can ultimately better manage our basins so we can have the groundwater to rely on in future droughts as well. So just again, want to thank everyone. If you haven't already, please check out the AEM webpage. The team has done a great job in putting great information there, the video that is there. And then as you have additional questions, please don't hesitate to email us at that aem@water.ca.gov. So we'll sign off for now and appreciate everyone's interest and continued work on this project. Have a good rest of the day.